Welcome back to freehighschooleducation.com. Today we are going to do the second session of the exercises of chapter 4.3, page 138. In exercises 15 to 20, complete the statement by writing never, sometimes, or always. Number 15, the sum of any two consecutive integers is never even. One of them is going to be even and the other one is going to be odd, and when we add them, the sum is going to be an odd number. Number 16, the sum of any two consecutive even integers is always even. Here we have two even numbers, for example 4 and 6, and both have 2 as a factor in them. So when I add them, I can factor 2 out. And 2 is going to be a factor in their sum. Here we added them and their sum is obviously 10. And you can see that 2 is part of the sum. So here the sum of any two consecutive even integers is always even. The sum of any two consecutive odd integers is never odd. Why? Because we have an odd number inside our odd number or an odd unit. I can split this into 4 plus 1, and the consecutive one will be 7, and I can split it into 6 plus 1. These two ones will add up and give an even number, and these two are even, so the sum is going to be an even number. Number 18, the sum of any three consecutive even integers is always even. This is similar to number 16. Number 19, the sum of any three consecutive odd integers is always odd. These two odds will give us an even, and if we add another odd, now we have an odd with the evens, and we get an odd sum. Number 20, the sum of any four consecutive integers is never odd. Again, we have four consecutive integers. Let's say 1, 2, 3, and 4. These two will give us an even sum, and these two will give us an even sum, and all together will give us an even sum. So it's never odd. Number 22, this is a special type of question. Here we have to prove the following. Show that for all integers n, if n plus n plus 1 equals s, then n equals s minus 1 over 2. So, if we have two consecutive integers, this is the first and this is the second, and their sum is s. So this is given in general, basically. Then we have to prove that n equals s minus 1 over 2. The way we prove these is we open the parentheses and add. We take 1 to the other side, and now we divide everything by 2. So n equals s minus 1 over 2. And we have proven this question. Now, number 23. Show that for all integers n, if n plus n plus 2 plus n plus 4, so here we have three integers. They may be odd or even, it doesn't matter, and their sum is s, so n plus n plus 2 plus n plus 4, and their sum is s. Show that in this case n equals s minus 6 over 3. Again, we remove the parentheses and we combine like terms, so that will be 3n plus 6 equals to s, 3n equals to s minus 6, and we divide by 3, and we have n equals s minus 6 over 3. And we have proven number 23. And with this, we come to the end of the session. We hope to see you again.